So in our last example problem, we had a highway, we had a truck, and the truck was driving down the highway here at 50 miles per hour, and there was a car coming up behind it. Okay. I'm going to have to excuse my lack of artistic abilities here. Okay, so the car was going here, and we said the length of the car was 11 feet when the car was 25 feet behind the truck, pulled out to pass. The truck was 44 feet long, and the car moved in front of the truck after it cleared it by 30 feet. Okay, so now we're gonna basically this is the same. We're gonna do the same problem except with a little bit of a twist to it. Okay, so once again, we're gonna say that the truck is going at 50 miles per hour. So 50 miles per hour, same conversion that we had before. That's 73.3 feet per second. Okay. Now, we're going to make this more complicated, though. We're now going to say that the car is driving behind the truck, waiting for a chance to pass. And so the car is so the velocity of the car initially is going to be equal to 50 miles per hour. Okay, then as soon as the opposing lane is clear, and the car pulls over to pass, the car accelerates, and the car accelerates at 7.3 feet per second squared until it is moving at 65 miles per hour. Okay, then it continues moving at 65 miles per hour until the pass is complete. Okay, so you see what's happening. You've got the truck moving along, the car's moving along at the same speed of the truck, and as soon as it gets clear, accelerates. Once the car reaches 65 miles per hour, the driver does not keep accelerating, goes that same speed, and then passes the truck. Okay, so I have the same question that I had before. How long does that take, and how far down the road does the car go while it's passing the truck? Okay, so we got this question, and so we say, well, how do we do that? Well, we've got the same basic layout here, that we got the car, we got the truck. The distance from here to there is still 110 feet. Okay, so what I can do is I can put my axis right here. Okay, and the axis is moving with the truck. Okay, and so that means the truck doesn't move, so the relative distance the car has to go, so this is going to be the relative distance right here, so that's going to still be 110 feet. And so what happens is the car initially, the relative speed of the car is 0. The car accelerates at 7.3 feet per second squared. Well, until it's going 65 miles per hour. Well, 65 miles per hour, like last time, is 95.3 feet per second. So that means the relative velocity, like last time, is 22 feet per second. So it accelerates at 7.3 feet per second squared until it reaches that velocity right there. Okay, and so that means that the time it takes to reach that velocity, okay, so V equals V naught plus AT, So that means that T is going to be V over A. So 22 feet per second divided by 7.3 feet per second squared. And that comes out to be 3.01 seconds. Okay, so how far did the car go relative to the truck in that 3 seconds? So x naught plus v naught t plus 1/2 a t squared. X naught is 0, v naught is 0, so that's just 1/2 times 7.3 feet per second squared times 3.01 seconds squared, and that comes out to be 33 feet. Well, the car has to go a total of 110 feet, so it only went 33 feet in the first part. So for the very first part, the car went 33 feet. So now it's beside the truck, and now it's going to be going at constant speed, okay, from that point on, okay. And so how far does it have to go? Well, the original distance was 110 feet. It's already gone 33 feet, so it has to go 77 feet more. Okay, and it goes 77 feet more. Okay, this is the relative distance right here, so the relative velocity is still 22 feet per second. So 77 feet divided by 22 feet per second, that's going to be the additional time. And so that additional time is 3.5 seconds. Okay. All right. So, well, it's going constant speed for that, so that means the total time is going to be the 3.5 seconds it goes after it reaches speed, plus the 3.01 second before. Okay, I'm being a little bit sloppy here, I guess, with displaying my significant figures. This should be 3.50 seconds. Okay, but the total time here is going to be 6.51 seconds. So that is the total time it took to complete the pass. Doing it this way, where you're accelerating for part of the way and then going at constant speed. So the next question was, how far down the road? So how far down the road did the car go? Well, there's two parts of the problem. One part of the problem is accelerating, and the other part of the problem is going at constant speed. Okay, so how far down the road? Okay, well, you look at it and say, well, for this part right here, x is going to be x naught plus v naught t plus 1/2 a t squared. Now we're going relative to the road. So put origin right here. Okay, so relative to the road, so we need the velocity relative to the road. So the initial velocity was 73.3 feet per second, okay, and it went for 3.01 seconds while it's accelerating, plus 1/2 7.3 feet per second squared times 3.01 seconds squared. And so that first distance right here, I guess we can call this x1. That first distance right there is going to be 254 feet. Now, this distance right here, okay, so what we can do is say that the final distance is going to be equal to x naught plus v naught t plus 1/2 a t squared. Now that we're over here, x naught is 254 feet, because that's how far we were from the starting point, okay, plus constant velocity. It's now moving at 65 miles per hour. That's 95.3 feet per second, and it does this now for 3.5 seconds. And so that means the total distance is going to be 587 feet down the road. So by matching the speed of the truck first, then pulling out, accelerating, and then pulling in front, it obviously took longer to complete the pass than it did just pulling over while you're already going faster than the truck. Obviously, you can't do that if it's not safe to do it, but this does illustrate the differences. So this is the same problem, just two different ways of approaching it. In one case, well, I guess not two ways of approaching, but two scenarios using the same basic concept. So both of them using relative motion.